So all of you know the first assignment RIP configuration using packet tracer. Now we'll say one A assignment, one B assignment, that is access control list, configuring access control list using packet tracer. So what is access control list? These are basically set of commands. These are basically set of commands grouped together by a number or name that is used to filter traffic entering or leaving an interface. So when activating an ACL on an interface, you must specify in which direction the traffic should be filtered, right? So that may be inbound or outbound traffic. Inbound means as the traffic comes into an interface, so that is inbound traffic you have to get. And before the traffic exits an interface, that is outbound traffic, right? So in this particular fashion, you are supposed to configure it. So inbound ACLs, that is incoming packets, are processed before they are routed to an outbound interface. Right, so an inbound access control list is efficient because it saves the overhead of routing lookups if they were the packet will be discarded after it is denied by the filtering test. Right. So an outbound access control list, ACL means access control list. Here the incoming packets are routed to the outbound interface and then processed through the outbound ACL. Now there are certain facts related to the access control list. Like access control list comes into two varieties, numbered and named. Each of these references to access control list supports two types of filtering, standard and extended. Now, standard IP access control list can filter only on the source IP address inside a packet, whereas an extended IP access list can be filtered on the source and the destination IP address. Here in our this 1B assignment, we have to see the standard access list and extended access list. Now there are two actions on access list control. They are nothing but permit or deny. You can permit IP address or you can deny. Then statements are processed in top-down approach. Suppose there are 4-5 statements in the access list. First statement processed first, then second, and so on. Once a match is found, so no further statements are processed. Therefore, order is important in ACL. So if no match is found, the imaginary implicit deny statement at the end of the ACL will be there. Right. So if you want to permit something, you need to explicitly write down their permit. Otherwise, it will execute the deny. Then an access control list should have at least one permit statement. Otherwise, all traffic will be dropped because of the hidden implicit deny at the end of every ACL. Then, no matter what type of ACL you use, standard extension, though you can have only one ACL per protocol, per interface, and per direction. For example, you can have only one IP access control list inbound on an interface and another IP ACL outbound on an interface. But you cannot have two inbound access control lists on the same interface. Always remember this. Only one, maybe inbound or outbound ACL on the interface, but not two. Now there are access list ranges. Say for the standard IP standard, that is standard access list, the range is 1 to 99. Extended access list, the range is 100 to 199. Standard expanded range is 1300 to 1999, and extended expanded range is 2000 to 2699. So we'll see the standard and the extended ACLs. Now standard ACLs, a standard IP access control list is simple. It filters based on source address only. This statement is important. It filters the traffic based on the source address only. So you can filter a source network or a source host. Here important, we can filter a source network or a source host, but you cannot filter based on the destination of the packet, the particular protocol being used, such as transmission control protocol or the UDP on the port number. Right? So you can permit or deny only source traffic. Now extended ACLs in extended access control list gives you much more power than just a standard access control list. When extended IP access control list check both source and the destination packet addresses, they can also check for specific protocols, port numbers, and other parameters, which allows administrators more flexibility and the control. Now named ACL, that instead of number 1 to 900 or something, you can use the number. You can use named instead of that. Like for example, say deny mic or something like. It's more meaningful than simply numbering one like this. There are certain configuration guidelines here in access control list configuration. Order of statement is important. Put the most restrictive statement at the top of the list and the least restrictive statement at the bottom. Access control list statements are processed top down until a match is found, and then no more statement in the list are processed. If no match is found in the access control list, the packet is dropped. That is implicit deny will be there. So each access control list needs either a unique number or unique name. The router cannot filter traffic that it or itself originate. Now you can have only one access control applied to an interface in each direction, maybe inbound or outbound. So you can't have two or more inbound or outbound access controls applied to the same interface. Always keep in mind. So applying an empty ACL to an interface permits all traffic by default, right? So in order for any ACL to have implicit deny statement, you need to at least one actual permit or deny statement should be there. Remember the numbers you can use for access control list, like standard access control list, we can use number ranging 1 to 99 and 1300 to 1999. And for the extended ACLs, we can use 100 to 199 and 2000 to 2699. There is a concept called wildcard mask. It's not a subnet mask. Like an IP address or a subnet mask, a wildcard mask is composed of 32 bits when doing the conversion. Subtract each byte in the subnet mask from 255. Now, for example, there are two special types of wildcard masks here in this case, 0.0.0.0 and 255.255.255.255. Now here 0.0.0.0 wildcard mask is called a host mask. This is the host mask. And this 255.255.255.255, if you enter this, the router will cover the address and mask to the keyword only. Now where to place this particular access control is? Standard ACL should be placed as close to the destination devices as possible. Always remember. And extended ACL should be placed as close to the source device as possible. These 2 points are there. That will see means how we can placing this. Then we'll focus on the standard access list now. First of all, standard access list. Now, because standard access list filters only traffic based on source traffic, all you need is the IP address of the host or subnet you want to permit or deny. So access control lists are created in global configuration mode and then applied on an interface. Now, syntax for the access control list is like this. Access list, say any one number from 1 to 9999 of this one. You should have permit or deny and the source address and the wildcard mask, that is optional. Now how we can use, if you are not using wildcard mask, you need to paste a host source address like this. Now, access control list. Now here just see already you are learned one assignment, that is routing information protocol that you are implemented. So you are using RIP running topology, which we have created in our earlier practical. You can consider this scenario or the scenario that I taught in the practical, that in the simulation. You can use anyone, but RIP communication you can have there. Now here say for example, you are having two routers, router 1 and router 2, right? Then 4 switches like 1, 2, 3, 4 switches, and each switch is connected to 2 PCs like this. So this is network 10.0.0.0, this is 20.0.0.0, this is 40.0.0, this is 30.0.0, and in between these two routers there is 50.0.0.0 router network is present. Now this PC is having IP address 10.0.0.2, 10.0.0.3, same way 10.0.0.2, 20.0.0.3, and same for this 30 and 40 like this, right? Now the basic steps to configure standard access list. Now you need to follow all means configuration of LAN interfaces, configuration of WAN interfaces, RIP config, all those things you have to do. Now then to configure the standard access list, use the access list global configuration command to create entry in the standard access list. First of all, you have to create the standard access list. Then you have to go to the interface mode and select an interface to which you need to apply the ACL. Right. So these are the interfaces you need to select where you need to apply the interface. Now use an after that third IP access group interface configuration to activate the existing ACL on an interface, maybe inbound or outbound. Now here with access list you will have variety of uses for the wildcard mask, but typically you can use match a specific host, match an entire subnet, match an IP range, match everyone and anyone like this. Say for example match specific host, that we'll see here. Now task is, suppose you have given a task to block 10.0.0.3. Suppose this 10.0.0.3 you need to block suppose this machine by gaining access to this 40.0.0, right? That means we need to block 10.0.0 from gaining access to 40.0.0.0. Now while this 10.0.0.3 must be able to communicate with networks, right? Other networks, it is in position, that means 20.0.0 it should communicate. So other computer from the network like 10.0.0.0 must be able to connect with network 40.0.0.0 like this. That should be the scenario. But decide where to apply this ACL and in which direction. Now our host must be able to communicate with other hosts except 40.0.0. So we will place this access list on fast Ethernet 0/1 of R2 because our host must be able to communicate with other host of this particular 40.0.0. That means this particular machine should be in position to communicate with the rest of this page. Only this we need to restrict, right? So we are supposed to place this particular ACL closest to the, I think, destination. So destination is this network. So for this network, this R2 router is the closest interface here. So we are going to put ACL here, right? So on 0/1 fast Ethernet we are going to put it, which is connected to the network. The direction will be outside as packet will be filtered while it's leaving the interface. The direction will be outside as packet will be filtered while it's leaving the interface. So if you place this list on R1, then the host, this particular 10.0 will not able to communicate with any other host including 40.0.0. If you place this ACL over here, then this host will not able to communicate with any of the network. That means this, right, like this, right? So, and you are placing that ACL on this interface, not this one. You are placing on this particular interface. So what are the command to configure R2? You need to double click R2 and select save command line interface. Say enable configure terminal, and then you need to enter config access list 1 deny host, say 10.0.0.3. That's it. Then access list, you are going to the config access list 1 permit any, then any other you are permitting. And you are going to the interface mode. Now interface fast Ethernet 0/1 and R2 config if IP access group 1 out, that is coming out of that particular interface traffic you are going to block for this particular 10.0.0. Or instead of that you can also have access list 1 deny 10.0.3 and this wildcard mask you can use, right? If you are not using this host word, you have to use this one, right? And then other rest of the thing is as it is. Now to test this, first do ping from 10.0.0 to 40.0.0.3. That means you are going to click on this particular machine and from this you are pinging this particular 40.0.0.3. Then it should be request timeout as this packet will filter by ACL, right? Then if you ping 30.0, it should be successfully replayed like this. If you ping this one, it will say timeout. That means your option is successful. So in this particular fashion, you can go about this particular assignment. Suppose if you want to give a task that a network that 10.0.0 from gaining access to 40.0, right? While this 10.0.0 must be able to communicate with networks. So you can use the commands like deny this network, the entire network, and permit any. So this entire network will be denied. Both the hosts will not going to communicate. That will going to happen. So this is called the access control list. How you can apply this particular access control list, right? So you can do in this particular fashion. So for this, say for example, if I mean, say for example, open. If I am opening new, suppose I think we'll consider this. Suppose this information we're going to consider. Just we're going to check all its. It will take few time to get all the green actually. This RAP already implemented. Here 192.168.1.0 network is there. Suppose I'm using another network. You can take anything and you can try it out. 10.0.0.0. This, suppose this is 192.168 dot, what is that, 2.0. just check. I will just click करके बताता हूँ मैं आपको. Where IP addresses are set, right? For this machine also I am setting the IP address 2.2, right? Now these two machines are there. So if I'm using one more machine here, say uh, here, and I'm placing this, and I'm saying this machine should be like 192.168 dot what is that 1.3, and now default gateway 192.168.1, right? Okay, and suppose I'm taking one more machine here on this network, suppose this one, this and I will connect it, and IP address I will going to specify as a 192.168.2.3, and gateway to 192.168.2.1. Fine, right? Let's let it become green. Sometime it will take some time. Okay. Now, when you go to this particular router, just check configuration fast Ethernet 0/0. Okay, fine, done. Already करके रखा है. I'm just in the previous assignments उसका use कर रहा हूँ. Because if you see it's a 0/0 with fast Ethernet, and this is serial interface, right? So here it's serial 2/0 10.10.0.2 and the clock 6, and that's it. Here also say configuration fast Ethernet 0/0, and serial is 10.10.0.3 and on, right? Because it's 0/0 and this is serial 2/0, like this. Then if you RIP का I already told you the RIP से हमने ये करके रखा है, then setting, that means we have added the networks and save. Here also using RIP we have added these two networks and setting and save, like this. Okay. This means connected. If you say, if you're trying to drop a packet from this, say for example take a packet here, and so for example from this machine to this machine, just check here. Simulation mode is send the packet, right? Like this. Successful, right? So it's working. Then go to the real-time mode. Suppose here I want to I'm writing here their IP addresses. Say for example, please note this is 192.168.1.3, and this is 1.2, this is 2.2, and this is 3, right? Machine IP address. Now I want to block this particular host by gaining access to, say for example, this 192.168.2.0, right? 192.168.2.0 network. So I can now this is source and this is destination, so my SSL should be placed on this particular router. So here I am supposed to click on this particular router, go to command line interface, and here I am saying enable, and I will say configure terminal conft, and there I will say access these commands. Actually these commands you are supposed to write down. This access list 1 deny host and the number. Access list 1 deny host. What is that host? 192.168. 1.3, right? And then I have to write down the next command, that is access list 1 permit any. This list 1, and I will say permit any other host are permitted from that network. And then I have to configure that particular interface. Now which interface? Here, that means interface fast Ethernet 0/0. That means in here this interface, because this particular fast Ethernet 0/0 on this router is out traffic we are supposed to block here in this case. So I will write interface fast Ethernet 0/0, right? We are in the interface mode, and I will say IP this command now, IP access group 1 out, IP access group 1 and out, that is outbound traffic, right? Okay, so in this particular fashion you can do. And then this is standard accesses that we are actually discussing. And then this thing requires some time for configuration. Then I will go to router, say config, and in the setting I will say save, right? Save. Then if I click on this particular machine, say for example, and say go to command prompt, if I ping 192.168.2.3, so it's not going to ping, right? It is blocking that particular address. That means request timeout. Got it? So in this particular fashion, this 2.3 is denied access, right? It's request timeout, correct? So in this particular fashion, you can implement this particular request. Like this. Then you can add more networks here. So that means one more interface, switch, another machines, and this machine can send packet to another machine. That is okay. That also that can be done here. So it's now pinging this machine to this. So in this particular fashion, you can implement this particular standard access list. Okay. Now come to the extended access list. We have taken different scenario. You can take this scenario, right? Maximum terminals you can work out. It's up to you. No, extended access list. An extended access list gives you much more power than just a standard ACL. So extended IP access list checks both the source and the destination packet addresses. So they can also check for specific protocols, port numbers, and other parameters, which allow administrators more flexibility and the control. Right now, here what you can do, access list number, permit and deny, that means access list. Now here this 100 to 199 hota hai extended mein, so access list number will be from say 100 to 199, any number, say 100, permit or deny. protocol source wildcard that you can use. Destination you can route on their wildcard. So the access list is the main command. Access is number between 100 to 199 here. Permit and any, that means this permit and indicates whether this entry allows or blocks the specified address. Then this protocol, that means IP, TCP, UDP, ICMP, right? Protocol. Source and the destination. So source identify source and destination IP addresses. Source wildcard and the destination wildcard. The source and the destination wildcard. So the operator can be say LT, that is less than, or GT greater than or equal to or not equal to. Right. The port number reference can be either the source port or the destination port, depending on where in the access control list the port number is configured. Now, as an alternative to the port number, well-known application names can be used such as Telnet, FTP, and SMTP. Right. 23, whatever, 20 or 21 accordingly. Then establish, because for FTP that is 20 and 21, no, port number. Establish, that's this one, that means for inbound TCP only. Now here inbound TCP only allows TCP traffic to pass if the packet is response to an outbound initiated session, right? And log, that is sends a login machine to the console. Now before you configure this extended access list, you should say some port numbers like 20, that is port number 20, that is TCP, and that is the FTP data. IP protocol is FTP data. Port TCP 21, that is FTP control port. 23 TCP port, that is Telnet. 25 TCP port, that is simple mail transfer protocol. 53 TCP port UDP, that is DNS, domain name system. 69 UDP port, that is TFTP, and 80 TSP port, that is HTTP. Right. So here we'll discuss the extended access list. Now here consider say the scenario here. The same R1, R2, 4 switches and 8 computers. Again, here's basic step. Use the access list global configuration command to create an entry in the extended ACL. Now use an interface configuration command to select an interface to which to apply the access control list. And third, use the IP access group interface configuration command to activate the existing ACL on an interface. Right. So now with access list, you will have a variety of uses for the wildcard mask. Or typically, say for example, you can do block host to host, block host to network, block network to network, block telnet access for critical resources of company, limited FTP access for users. So these things you can do. Here, say for example, what the simple thing you can do here. You are the network administrator access computernetworking.com. So your company hire a new employee and give him a PC set 10.0.0.3. Say for example 10.0.0.3. This PC is given to you, suppose, huh? And your company's critical record remain on 40.0.0.3. Your company record is present, suppose, on this particular machine. Which one? 40.0.0.3, this machine. And so you are asked to block the access of this 40.0.0.3 from 10.0.0.3. While this 10.0.0.3 must be able to connect with other computers of network to perform its task. Right? Now here, first thing, we need to decide where to apply access control list and in which direction. As we are configuring the extended access list, with extended access list, we can filter the packets as soon as it generate. So we'll place our access list on fast Ethernet 0 of router 1 nearest to the port of this particular 10.0.0.3. Just a packet image generate होते हैं ना, that means this router, that is it is applied nearest to the source. So यहाँ पे source होता है ना, you need to block the access of this, that this computer 10.0.0 should not access this 40.0.0.3. So you are supposed to configure your access list in R1 here. In previous standard, you have configured access control list on the this R2, but here now we are going to configure nearest to the device where the packets are generated. So we are applying at R1, and so we'll place access list on that particular interface and the nearest port of it. That means this interface पे हम करेंगे. Then this router R1 is nearest port for this computer 10.0.0.3. So what we can do? Click on R1 router, say enable configure terminal, and there you are writing access list 101, deny IP host, this and the specific terminal, right? Then R1 access list 101 permit IP any right, like this, and say R1 config interface fast ethernet 0/0 IP access group 101, that is this 101 here and here, they are the stating that this is the extended access list, and inbound traffics that we are supposed to consider, right, and exit. You can vary by doing ping from 10.0 to 40.0. It should be request timeout, right? In blocks host to the network. Now, suppose you are blocking host to the network. That means this 10.0 is denied to access complete network 40.0.0. So you are specifying the complete network address here, right? So that is also possible. And suppose network to network access you want to block. So here complete 10.0.0 and complete 40.0 don't have access to each other, that you can specify like this. Then network to host, that means suppose access denies IP list, this is the network and this complete network doesn't have access to this particular network or specific terminal from that particular network, this one, that is also possible. So in this particular fashion you can configure this particular extended access list. There is application based extended access list also there. For example, in this previous example, we filter IP based traffic. Now we will filter application based traffic. To do this practical, either create a topology as shown in this particular figure and enable telnet and HTTP and FTP service on server, right? Or download this pre-configured topology and load it in a packet tracer, right? And then you can use this access list when permit TCP any establishment established, and then interface serial on this particular 000, you are imposing that particular access list. So that is also possible if you want to put access list in this particular manner. You can do, see, there is lot of things you can do. But first of all, you should be in position to know how you can do it. In your practical, I'm showing you one, two, three things that how to do. You can do rest of the thing by your own. The commands are there. Right now here, suppose I'm using suppose this router, suppose there are two more, you can say that for now extended access list, what I will do, extended access list, and I will take, say for example, one more switch here, right, and two machines, one, and suppose second machine if I'm taking here, and again I'm taking one more switch here, and say two more machines here and here, and I'm going to connect them. Right, then fine. Then just I will say this is my network as I'm mentioning it's, for example, 192.168.3.0, and this is suppose, and so this is my network 192.168.4.0, right? What will be terminal numbers over here? Suppose 192.168.4.2 is 4.3, This is 192.168.3.2, right? And this is 3.4. Right? Okay. And you configure this route. Now you need to configure this FA101 also. So this FA101, you can say here that address 192.168 dot and gateway will be 3.1. That's it. And you are making this on. And here you are making this as this is say 1.0, 1/0. So this is 1/0. So I can write down 192.168 dot, what is that, 4.1 gateway, right? I'm making this as on, right? So it's on, right? So then here, now see, both things are set. It will also become green. Just wait for a minute. It will take some time. Routing table routers take some time for updation. So they are connected now. Okay. Now green. So the complete network is ready. It's connected, right? So okay. Now in extended, you can say if I want to block this entire network, this particular machine to gain access to this particular say 192.168 using extended access list. So what you can do? So you are supposed to place that particular access list near to the port where the packets are generated. For this particular machine, this particular router is nearest. So we are supposed to place our access list here. What I will do, click here. I block this 3.4. Click here and say this CLI. So exit I will do first of all. Okay. Click command line. I will say enable config T, and here I need to follow this, say for example instructions like for example this one, access list 701. I'm saying access list 101, that is for this extended, and deny IP host this 100.73 and some configuration like this. So I can say deny IP host. Say for example here 192.168.3.4, right? And so destination is what this that 192.168 dot suppose 4.3, right? 4.3, or suppose you want complete network, you can use this and say right. Then you can use next access list 101 permit IP any access list 101 permit IP any. And then now you have to configure it on the interface of R1 router. Interface fast Ethernet. Now here where you are also going to configure it. Now just see here this one. This is fast Ethernet F1/0, right? So here you can configure it. Interface fast Ethernet 1/0, right? That is that rule. And what you are supposed to write in that, then IP access group 101 inbound traffic. IP access list 101 and inbound traffic. Sorry, IP access list 101. Sorry, IP access group, not list. IP access group 101 in, and then exit. These commands we are using for extended. Then once this is done, then you have to go here, click on this particular router, config settings, and say for example save. So this extended list you can access now. Say for example, if I'm in here 3.0 desktop command 192.168.4.3, this request timeout should be there. Yes, this request timeout for that. That means extended IP list also working properly. Got it? So I will just say this is the scenario for extended in our case, and you can use this accordingly. Okay. The same scenario you can use, this up to you what sort of things you are supposed to do, right? And this is standard scenario, and we can also check out the commands for them. Rest of the things also you can do with this. वन के हमने कमांड्स कौन से देखे थे राउटर वन के? Router 1, the same command that those we are using here for the router 1 actually, which are the commands for them. Okay, now this is what I can do that documentation later. In this particular fashion, standard and extended access list you can do. So that's all about assignment 2A. You can also do, you can take the scenario and do network to network, you can say access control list and other type of access control list.